Well, thank you so much, Stephanie and Mike, for inviting me to take part in this symposium. It's a pleasure to be here. And I'm going to start by introducing two of the NIH-sponsored consortium projects that I'm involved in that look at development across adolescence, and especially brain, but also various other behaviors. And in particular, how we are looking to implement mobile tech in these studies. I'm going to really focus most of my attention on one behavior in particular that's of interest to me, which is sleep. So I will talk about the importance of sleep in adolescence and whether we should consider using wearables to measure sleep. Can we get valid data out of these wearables? I'll present some data where we have been collecting from the ABCD participants, measuring sleep with a wearable. And then I'll finish off by also presenting some of the challenges for using wearables in research and clinical applications. So the ABCD study stands for Adolescent Brain Cognitive Development Study, and it's probably the largest study of its kind. It's studying over 11,000 adolescents across 21 sites in the USA. They started at age 9 and 10, and they're being tracked every year for the next 10 years. And we are currently in our second year of follow-up. So a lot of data collected so far, and lots more to come. And the focus is on brain development and child health. And the second study that I'll talk about is the National Consortium on Alcohol and Neurodevelopment in Adolescence, or in CANDA. This study is looking at more than 800 adolescents, also tracking them longitudinally. It had a bit of a different study design in that the starting age of the participants was between 12 and 21 years. And the focus of InCanda is to look at predictors and consequences of substance use, mainly alcohol, during adolescence. And these two studies are very much observational and basic research studies, but focusing on adolescence, we know, is a strong time for looking at as a time for prevention of adverse health outcomes in later life. And the hope is that with these studies, we'll learn a lot about potentials for prevention. So, with the ABCD study, just in broad description of the objectives, is to really study the individual developmental trajectories, for example, of brain development, and look at risk factors and for deviant trajectories, as well as factors that can impact development, considering genetic versus environmental factors, physical activity, sleep, emergence of mental disorders, and exposure to substances. And with all of these behaviors and factors that we're measuring, we really get a very rich data set to look at. And this data is sort of open science. It is available through the NIMH data archive. And already there has been a data release a month ago for all the baseline data that is now available for scientists to use. Early on in ABCD, we recognized the power and potential for including and considering mobile technology in ABCD. So we did start out with more with measures of self-report, where along with the other measures. So the participants come in for an intense lab visit for a day, where they have a core part of the ABCD component, which is an MRI brain scan. But then they also do neuropsych assessments, and they fill out lots of surveys about their behavior. And then we saw, well, wouldn't it be nice if we could get more detailed information, which can be accessed through mobile technology? So fairly quickly, we added a wearable, which allows us to track daily sleep-wake activity patterns in all the participants. And I'll talk about that mainly in the rest of my talk. And we're also on track to add a mobile phone app, which will allow us to track daily social media usage, total screen time duration, time of day of use within the participants. And we know there's a growing interest about the social media usage in teenagers. So we want to go beyond being able to just assess that using questionnaires and be able to passively collect that data from the participants and relate it to all the other measures that we are collecting within ABCD. Within Encanda, we've also been looking at how can we use mobile technology in this project. And since that one is very much focused on substance use, the group at UCSD, led mainly by Kevin Cummins, has been developing a customized mobile app called the mEncanda app, to more frequently assess substance use in the participants. So some of the assessments are done monthly or weekly, and there's even 1 week out of every year where they get daily assessments. And this is you can see on the right an example of what the surveys look like. So they get pushed to the participants, and we've now been doing this it was piloted at UCSD, and now we've just been rolling it out into the whole consortium. And it asks questions in a very quick couple of minutes survey. For example, this one is the monthly one. In the past 4 weeks, how many drinks have you, how many days have you consumed alcohol? And on those days, what was the average number of standard drinks that you consumed? And we can ask questions about substance use. We can also ask about their mood and sleep, activities and stresses, in a very brief and very instantaneous assessment using their phones. And the app is available on Android and iPhone, so we can use it across all groups. In this way, we're getting better accuracy, decreases the burden. We're going beyond just yearly or every 6-month assessments of substance use. So we just get much better resolution of the data. And we are using, you can see on the right, this is just the end screen where they get this response reinforcement, which we think is important to ensure that people continue responding to the surveys. They get earn credits for every submission that they provide, along with gift cards. And looking forward, what we're really interested in doing within this is combining information, and this would be relevant for both ABCD and Encanda. So we want to integrate information. So in Encanda, we're looking to use these surveys and combined with daily assessments of sleep and wake activity from a wearable, and then we can begin to look at relationships between these two behaviors. So I've mentioned sleep, and I really want to focus on sleep as an important factor during the teenage years. I mean, I think all of us hopefully know and realize the importance of sleep for everybody, but it's really critical during the teenage years. If they're not getting sufficient sleep, it has enormous impacts on many other aspects of their lives. But of course, during the teenage years, sleep changes a lot, and there's a lot of biological and social factors that drive changes in sleep. And shown in this figure are two of these biological changes, where at the top you can see your 24-hour circadian rhythm, and as a teenager progresses towards adulthood, they get a delay in their circadian phase. And what this means is that they are feeling alert for a lot longer into the evening and into the night. At the same time, researchers have shown that there's a slower build-up of sleep pressure during the day. So this also means that they are not feeling sleepy at the same time that they used to feel sleepy. So you put these two factors together, and anybody who has a teenager at home knows that they don't want to go to sleep very early, often wanting to stay awake till midnight, 1 a.m., which would be fine, except that school starts early in the morning, and so they have to wake up. So you get this pattern of during the week, they have this very truncated time for sleep, so not getting enough sleep, really. And then they play catch up on the weekend. So you get what's called social jet lag and seesawing from week to weekend, having this very irregular sleep pattern. And we can see this in our Encanda data. This is now based on questionnaire survey data. And you can see that in the blue, the blue triangles, whatever they are, that those are the school days. There's a much lower time in bed that the participants are reporting relative to the gray, which is the non-school days. And on the right, you can see the relationship between, showing that the people who are having the very short time in bed, like between 4 and 6 hours, are the ones who are having a major catch-up on the weekend. They're having like an additional 5 hours in bed on the weekend to try and catch up. So an important question that as sleep researchers we sort of grappled with and always get asked is, how much sleep does everybody need? The National Sleep Foundation has come up with some guidelines, and the guidelines for teenagers, so between, say, typically 14, 17 years old, would be between 8 and 10 hours of sleep. But of course, as we hear a lot in the news and know from yourselves, that a lot of teenagers are not getting that amount of sleep. And in fact, many surveys, including this one, show that only 30% of high school students report getting 8 hours of sleep or more on an average school night. So in this context of the teenager, with these changes that are naturally occurring with their sleep patterns and some of the constraints due to school times, and as well as the emergence of other things like insomnia becomes more common in teenage years, you get a lot of kids are suffering from consequences of poor sleep. It affects their mood, diet, exercise ability, increased risk for substance use, accidents, and poorer sleep performance. And this data, recent from just the end of last year, shows a dose-dependent association between sleep duration and unsafe behaviors among US high school students. And if you look at the gray circles, those are the group who are getting less than 6 hours, so very extremely short sleep. And you can see how far their risk factors are, the odds of having several unsafe behaviors are much higher in that group compared to the others, in particular for the impact on mood and self-harm. So there are severe consequences for getting insufficient sleep, which just shows the importance of being able to properly monitor sleep and intervene and improve sleep. In our own data, this is in Canada again, we've also looked longitudinally at sleep as a potential factor, poor sleep as a risk factor for substance use, and that's what's shown here is we find that at baseline, those who are reporting poorer sleep quality and later weekday bedtimes have a greater odds of binge drinking a year later. And we also find that they also have a greater odds of marijuana use too. Now, these are all self-report data, which is, as we know, subject to recall bias. So it seems as this would be a great opportunity in the adolescent population to try and measure sleep in a different way. So not have a minimal burden, be able to track sleep for more than one day, and also to look at something that is immediately assessed on a daily basis and then relate it to other behaviors. So what is available? Well, on the left, you can see that's the research-grade actigraphy, which has been around for more than 40 years and relies on activity measures. So if you're moving a lot during the nighttime period, then you would be said to be awake. If you're not moving, considered to be sleeping. It's very well accepted in research and clinical settings, and it has been validated against our gold standard polysomnography. It does have known limitations, which have been accepted in the literature. But then, in the last few years, we've seen this explosion of wearable sleep trackers, and it really is an explosion. I mean, there's multiple choices, multiple options, and they're very enticing and sound pretty nice for using, both for ourselves and potentially for research applications. They're great. They're designed around the user. People like to wear them. We know that teenagers really, really enjoy them. They're easy to use, flexible. You can access the data immediately. And they are more affordable than research-grade actigraphy. They do have a lot of big claims, but the performance is a little sketchy. So we have less information about the performance because the proprietary algorithms are used, and it's a bit like a black box. So can we rely on them? How valid are they? We can see that another aspect of the wearables is that they change very quickly. So it's not just one set of devices that just stays. There's multiple devices and also multiple generations of devices, where the second generations now don't only rely on motion, they start to include other sensors and can get at things like heart rate. And in this way are now beginning to open the door onto sleep and claiming that they could even measure things like REM sleep. So we, in our lab and others, have been interested in tracking and looking at the validity of these wearable sleep devices to see, compared to gold standard laboratory polysomnography, how well do they actually do? And there's two basic approaches that we take and that are accepted, and that's looking at Bland-Altman plots and seeing whether there is a deviation with the difference between the device and polysomnography compared to our gold standard polysomnography, and that's shown on the left. And then on the right is a bit more of a quantitative approach where you can look head-to-head, minute-by-minute epochs of sleep as recorded by the device versus the polysomnography and see where they differ. And from these approaches, we can see that wearables have a very high sensitivity in classifying sleep. That's above 90%, but lower specificity in detecting wake. And that's similar to the standard actigraphy as well. It is a good example to think of if somebody is lying in bed and they're awake, but they're not really moving that much, then that's very hard for these trackers to pick up that you are actually awake. So with the, when we look at the sort of results across several wearables, several validation studies, that's what's shown here, across the years from 2012 when they started being looked at. Those are shown in the black circles. And then the studies that have also looked at actigraphy compared to polysomnography are shown in the yellow circles. And you can see that in the top, showing the sensitivity, you can see that there is pretty close, a very, very standard level in all these validation studies showing a high sensitivity, whereas the specificity is, like I say, lower. But if you look at the box that I've highlighted in brown or yellow, these are the second generation devices. So these are now the devices that are using more than motion. So they're including other sensors like PPG, from which you can derive heart rate. And while they're not, there's fewer studies of those devices, there does appear to be an improvement in the specificity in detecting wake, which would make sense if you think of if you have got not only motion, but something else like heart rate to try and tell the difference between sleep and wake, that there is a potential for improvement. But there is a need for further studies because, again, it's just a too small a number. And you can, looking at across these studies, given the range of wearables where we have Jawbones, Fitbits, Oura Rings, many others, and then also you have the different generations, like every 2 years there's a new one. So even within Fitbit, you get these changes in the algorithms and changes in devices. And so every time it's challenging for validation studies to try and keep up. But it's important for validation studies because otherwise, if we're not comparing it to our gold standard, polysomnography, then we run the risk of collecting a whole lot of data that may be invalid. One more point I'll just raise with this slide is we ourselves and others have also looked at adolescent populations, and that's important because we want to use them in our studies of ABCD and NCANDA, which are focusing on that group, on that population. And you cannot assume that a device that works well in adults will also work in kids. Finally, this is just looking at the validity of studies of the wearables. This shows nicely the heart rate as recorded during sleep with a Fitbit device in our lab. And we found, at least during sleep, that the Fitbit was very accurate for recording heart rate. It was less than 1 beat per minute off compared to ECG, whereas there are bigger issues with the Fitbit during wake when measuring heart rate. So within ABCD, we did a pilot study, and I'll just present a little bit of the data so you can see what metrics we're getting out from the Fitbits. This was the pilot study really aimed to look at the feasibility of having the Fitbit in the ABCD study, where we wanted people to wear it for a 3-week period, day and night, and look at also how research assistants would work to even get this out into the population. So what I'll show now is some of the data that you can see. These are the outcomes from these 75 adolescents. It shows light sleep, deep sleep, REM sleep, wake. TST is total sleep time, and TIB is the time in bed or the period available for sleep. And I'll focus on the last two, the total sleep time and time in bed, since those are the more validated measures. And we can see that for weekends and weekdays that there really is no difference between the measures in our group, which is not surprising since these are young kids. They're 9 and 10 years old. So this would be before they start to show a big variability from weekday to weekend. We also saw that it's possible to look at, we can categorize our groups based on their total sleep time. So looking at their weekday sleep time, we see that there's about 11 of the kids from the 75 sample who have less than 8 hours of sleep as measured with the Fitbit. So they are shown in yellow, and we can see that even on weekends as well, they still have lower sleep time, lower time in bed compared to the other two groups. And looking at the bottom figure, you can see that the factor that's mainly driving the shorter sleep time in this group is that they are going to bed much later than the others. On the right is a measure of sleep efficiency, which is like an objective measure of sleep quality. And we can see that all of the kids actually have quite a good sleep efficiency. So it's above 87%, which is considered to be pretty good. They are spending most of the time sleeping in their periods of being in bed. We do see that there is a difference between the short sleepers in that they have got a slightly higher sleep efficiency, probably because they're but sleep deprived, and so they are falling asleep very quickly and sleeping hard during the night. This is just to give you just a taste of where we're going or why we are using Fitbit in the ABCD study, is we really want to relate a better and more detailed measures of sleep to other behaviors that we're recording within ABCD. And this is showing associations in the baseline, just our pilot, 75 kids, relationships between total sleep time as recorded from the Fitbit with depression symptoms and externalizing symptoms as assessed with the parent report of child behavior checklist. And we can see that the data corresponds with what we know from self-report data, which is that the kids with the shorter sleep time are more likely to have higher depression symptoms as well as more externalizing symptoms. And you can just see how we are now, this is just such a small subset of the sample, and as we are moving forward with our 11,000 kids, where we really are having them all using Fitbits if they agree to this part of the protocol, and we'll have these 3 weeks every year of Fitbit data to look at and to relate to brain structure, function measures, as well as the other behaviors like depression symptoms in a very large sample. So there's enormous promise of what is still to come. But we do need to keep aware that there are challenges to using consumer wearables in research and clinical practice. And that's what some of these are listed here. So clearly in ABCD, we've made the choice to use a wearable for many reasons. It's affordable, it's liked by the participants, and it's easy to use and easy to track. But sometimes the ease of use can be deceptive into us believing that the data is also just easy to use and valid. So I think just need to be a little word of caution is that still keeping in mind that there is minimal validation available in healthy populations, so there needs more studies for that, and in clinical populations. So you can imagine if somebody has a sleep problem and they maybe are spending a lot more time awake during the night, given some of the limitations of wearables and actigraphy, it may not be as accurate in those clinical populations. Also, we can get the minute-by-minute post-process data, but we cannot access the raw data. So we can't use our own algorithms to analyze the data. We have to rely on the black box of whatever device it is that you choose to use. And also, while they are coming out with other sleep metrics like deep sleep, light sleep, REM sleep, it's still largely unproven, and a lot more work still needs to be done to determine, well, how valid can it be to measure REM sleep, for example, and what does it even mean? Or what would we do with that information? And for our point of view as well, for longitudinal studies, it's good to remember that the algorithms can be changed without notice by the commercial company. And that's something that we have to keep in mind as we use them over time. And also to keep track with the developments and advances that are made. Finally, just 2 points if we were to consider these being used clinically, because they also have a lot of advantages. They can start a conversation with the provider about their sleep. But it has to be remembered they're not FDA regulated for any diagnostic or treatment purposes. And it can lead to consequences like underestimating or overestimating a sleep problem. So taken together, I think that we have this possibility of using mobile technology in our research studies, currently ABCD in particular, and we'll be able to track get a whole wealth of information about sleep and wake activity in adolescents as they grow older, which can provide phenomenal information that can be used later to determine deviations in trajectories in some of those kids. So I think using them is a strong addition to our studies, but we do always need to keep in mind a little bit of caution as to how to use that data and interpret the data. So I'll just end with acknowledging the funding from NIH and our Sleepy Sleep Laboratory, in particular Massimiliano Desambati, who does a lot of the validation studies, Amy Goldstone, and Devin Prouty. Thank you very much.